city without disturbing a single building above your head. Imagine digging through solid rock beneath mountains, rivers, and even oceans, while millions of people continue their daily lives only a few meters above the construction site. For centuries, projects like these would have been considered nearly impossible. Engineers relied on explosives, manual excavation, and slow, dangerous construction methods that often took decades to complete. Every tunnel represented enormous risks: rock collapses, flooding, deadly dust, unexpected geological conditions. Thousands of workers lost their lives building the tunnels that connected our modern world. But everything changed with the invention of one extraordinary machine, the tunnel boring machine, better known simply as the TBM. Today, these engineering giants operate silently beneath some of the world's largest cities, carving their way through solid rock with incredible precision. Most people never see them. While traffic flows across highways, trains race through underground stations, and skyscrapers rise above busy streets, enormous machines continue working far below the surface, 24 hours a day. Some of the largest tunnel boring machines ever built are longer than 2 football fields. They weigh thousands of tons. Their rotating cutter heads contain hundreds of hardened steel cutting discs, powerful enough to crush solid granite, limestone, and reinforced concrete. Behind the cutter head, an entire underground factory moves forward piece by piece. Hydraulic systems push the machine through. Conveyor belts remove thousands of tons of excavated material. Robotic equipment installs massive concrete tunnel segments with incredible accuracy. Every movement is carefully monitored by engineers using advanced sensors and computer systems. Without tunnel boring machines, many of today's most ambitious infrastructure projects would simply be impossible. Modern subway systems, high-speed rail tunnels, underground highways, water transfer projects, hydroelectric systems, even tunnels stretching beneath the ocean, all rely on this remarkable technology. But building a machine capable of drilling through mountains is only part of the challenge. How can something this enormous survive crushing underground pressure? How does it continue operating when it encounters different types of rock, underground water, or unstable soil? And how can engineers guide a machine weighing thousands of tons with millimeter-level precision beneath some of the busiest cities on Earth? To answer those questions, we first need to look inside one of the greatest engineering inventions ever created. Because once you understand how a tunnel boring machine actually works, you'll realize that it is far more than just a giant drill. It is a moving underground factory that has completely transformed the future of construction. At first glance, a tunnel boring machine looks like nothing more than an enormous rotating drill. But in reality, it is one of the most sophisticated engineering systems ever created. Every section of the machine performs a different task, and all of them must work together with incredible precision. At the very front sits the cutter head. This massive rotating wheel is covered with hundreds of hardened steel cutting discs, specifically designed to crush different types of rock. As the cutter head slowly turns, enormous hydraulic cylinders push the entire machine forward with tremendous force. Instead of cutting through rock like a conventional drill, the discs apply extreme pressure until the rock fractures and breaks apart. The broken material immediately falls onto a conveyor system positioned behind the cutter head. From there, thousands of tons of rock are transported through the machine and carried out of the tunnel without interrupting the excavation process. This continuous operation allows modern tunnel boring machines to work day and night with remarkable efficiency. But digging the tunnel is only one part of the job. As the machine advances, the tunnel behind it must remain stable. If the surrounding ground collapses, the entire project could be placed at risk. To prevent this, tunnel boring machines act like moving underground factories. Behind the cutter head, robotic systems automatically install enormous precast concrete segments. These heavy concrete rings are carefully lifted into position one piece at a time. When the final segment locks into place, the ring becomes a permanent support structure capable of resisting the immense pressure of the surrounding A small navigation error could have serious consequences. To avoid this, laser guidance systems and computer-controlled navigation continuously monitor the machine's exact position. Some of today's largest tunnel boring machines can maintain alignment within only a few millimeters over distances of several kilometers. Different environments require different types of machines. Hard rock tunnel boring machines are designed to crush solid granite at constant pressure. Earth pressure balance machines are used in soft soil essential to prevent surface settlement. Slurry tunnel boring machines use pressurized liquid systems to stabilize water-rich ground while excavating rivers, lakes, and coastal regions. Each design is carefully engineered for the geological conditions that they encounter. Without the correct machinery, even the most experienced engineering team would struggle to complete the project safely. Yet despite their enormous size and incredible complexity, tunnel boring machines remain unlimited. Their success ultimately depends on thousands of engineers, technicians, operators, geologists, and construction specialists working together with absolute precision. Every tunnel completed beneath the city represents years of planning, countless engineering calculations, and millions of individual decisions. It is this combination of human expertise and extraordinary technology that allows tunnel boring machines to achieve what once seemed impossible. And as engineers continue pushing deeper beneath mountains, rivers, and even oceans, these remarkable machines are opening the door to an entirely new future beneath the Earth's surface. Building a tunnel is never simply a matter of digging a hole. Every meter beneath the Earth's surface presents a new challenge, and no engineer can predict exactly what lies ahead. Hidden behind layers of rock and soil are underground rivers, unstable ground, fractured land formations, pressurized water, and geological walls that have one unexpected discovery may stop an entire project within seconds. Imagine a tunnel boring machine weighing more than 2,000 tons moving slowly beneath the surface. Everything appears to be operating normal. Then suddenly, the machine encounters a pocket of water trapped deep underground. Within moments, thousands of liters of water begin rushing toward the excavation face. Without immediate action, the tunnel could flood, equipment worth hundreds of millions of dollars could be damaged, and workers' lives could be placed in serious danger. Situations like this are exactly why modern tunneling projects depend on constant monitoring. Hundreds of sensors continuously measure pressure, vibration, groundwater levels, machine performance, and the stability of the surrounding ground. Every second, enormous amounts of data are transmitted to engineers working inside the control. Even the smallest change can trigger an immediate inspection. Ground conditions also change much more often than people realize. A machine may spend several days cutting through relatively soft soil before suddenly reaching an area of extremely hard ground. Just a few meters later, that same tunnel may pass through fractured rock filled with underground water. Each geological layer requires different operating speeds, different cutter pressures, and sometimes completely different excavation strategies. If engineers push the machine too aggressively, cutting tools wear out much faster. If they move too slowly, construction schedules fall behind and project costs significantly. Finding the perfect balance requires years of experience. Another major challenge is protecting everything above the tunnel. In crowded cities, tunnel boring machines often travel beneath apartment buildings, highways, bridges, subway lines, hospitals, and historical landmarks. The ground above cannot be allowed to settle, even by a few centimeters. A small movement beneath the surface could create cracks in buildings or damage existing infrastructure. To prevent this, engineers constantly monitor surface movement using satellites, laser cameras, GPS systems, and thousands of ground sensors installed around the construction zone. Many people are surprised to learn that modern tunnel boring machines can travel directly beneath rivers and even beneath the ocean. Projects such as underwater railway tunnels require extraordinary precision. Water pressure increases dramatically in depth. If the excavation fails to lose pressure for even a short period, water and soil can rush into the tunnel with tremendous force. That is why slurry tunnel boring machines continuously maintain balanced pressure at the excavation phase, allowing them to move safely through water-saturated ground. Even the cutting discs themselves face enormous stress. Each steel cutter experiences Despite all these challenges, tunnel boring machines continue advancing. We anticipate day after day, month after month. Some of the world's largest tunneling projects require years of continuous excavation before the two ends of the tunnel find. When that moment arrives, the difference between the two excavations is often measured in only a few minutes. A remarkable achievement considering they have been drilling through solid rock for kilometers in the city. Every completed tunnel is far more than a structure. It is proof that careful planning, advanced technology, and human determination can overcome some of the most difficult environments on Earth. And yet, the most astonishing tunnel projects are still ahead of us. Because engineers are no longer building tunnels simply to connect two places. They are beginning to imagine entire underground worlds. Today, tunnel boring machines are doing far more than digging transportation tunnels. They have become the foundation of some of the largest infrastructure projects ever attempted by humanity. Across Europe, Asia, and North America, these engineering giants are helping reshape entire cities beneath the surface. One of the greatest examples is the Gotthard-based tunnel in Switzerland. Stretching for more than 57 kilometers beneath the Swiss Alps, it is the longest railway tunnel ever constructed. Building it required years of excavation through some of the hardest rock formations in Europe. Tunnel boring machines work continuously beneath towering mountains, where temperatures, geological pressure, and complex rock conditions push both the machines and the engineering teams to their limits. When the tunnel finally opened, it transformed transportation across the continent by dramatically reducing travel times and improving freight movement between northern and southern Europe. Another remarkable achievement lies beneath the English Channel. The Channel Tunnel connects the United Kingdom and France through a series of underwater tunnels extending for approximately 50 kilometers. Excavating beneath the seabed required extraordinary planning and precision. Engineers from both countries worked toward each other from opposite sides of the channel. After years of excavation, the two tunnel sections met with astonishing accuracy, proving just how precise modern tunneling technology has become. Meanwhile, beneath some of the world's busiest cities, tunnel boring machines continue expanding underground transportation networks. Cities such as Tokyo, Singapore, Shanghai, and London depend on continuous tunnel construction to support growing populations. Instead of building upward forever, many governments are investing billions of dollars beneath the surface. New subway systems, underground expressways, utility corridors, flood protection tunnels, and massive underground service networks. Every one of these projects relies on the same remarkable engineering principle: dig safely, build accurately, protect everything above. Modern tunnel boring machines are also playing an important role in renewable energy and water management. Hydroelectric projects use deep tunnels to transport enormous volumes of water. Water transfer systems move fresh water across entire regions. Stormwater tunnels help protect major cities from catastrophic flooding during extreme weather events. As climate change increases pressure on urban infrastructure, underground construction is becoming more important than ever. But engineers are already looking beyond today's projects. Future tunnel boring machines may become even larger, faster, and smarter. Artificial intelligence could monitor every component in real time. Autonomous control systems may optimize excavation without constant human intervention. Advanced sensors could identify dangerous geological conditions before the cutter head ever reaches them. Some researchers are even developing robotic inspection systems capable of repairing tunnel linings without interrupting normal operations. These innovations could dramatically reduce construction costs while improving safety and efficiency. For centuries, humans expanded across the surface of the Earth. Now, for the first time in history, we are beginning to expand beneath it. Every new tunnel represents more than a transportation route. It represents another step toward a future where underground infrastructure becomes just as important as the cities above. And perhaps one day, the same machines building today's tunnels will construct something even more ambitious. Not just another railway, not another highway, but an entire underground city. For more than 2 centuries, humanity has focused on building upward. We built taller skyscrapers, longer bridges, larger airports. Entire cities expanded toward the sky. But today, a new frontier is quietly emerging beneath our feet. Every tunnel completed by a tunnel boring machine is doing more than connecting 2 places. It is expanding the underground world that future generations may one day depend upon. Engineers are already designing underground transportation systems that move millions of people every day. Massive utility tunnels now carry electricity, clean water, communication networks, and essential infrastructure beneath modern cities. Flood protection tunnels help defend entire communities from increasingly extreme weather. Some countries are even exploring underground logistics systems where autonomous vehicles transport goods without adding traffic to city streets. The next generation of tunnel boring machines could become even more intelligent. Artificial intelligence may continuously analyze geological conditions in real time. Predictive maintenance could detect worn components before failures occur. Autonomous navigation systems may guide machines with even greater precision, allowing projects to be completed faster, safer, and at lower cost. As technology improves, engineers may begin constructing projects that once belonged only to science fiction. Underground research laboratories, massive energy storage facilities, entire industrial districts hidden beneath the surface, and perhaps one day, fully self-sustaining underground cities designed to protect millions of people from overcrowding, climate change, and extreme weather. The machines making that future possible are already here, quietly working beneath mountains, rivers, and some of the world's busiest cities. Most people will never see them, yet almost everyone will benefit from the tunnels they create. Every subway journey, every underground railway, every tunnel carrying clean water or electricity, every engineering project built beneath the earth begins with one remarkable machine. The tunnel boring machine has become one of humanity's greatest engineering achievements, not because it is the largest machine ever, but because it allows us to build where previous generations believed construction was impossible. Perhaps the future of civilization will not only be measured by how high we build, but by how deeply we are willing to explore beneath the earth. And if one day entire underground cities become reality, history may remember the tunnel boring machine as the machine that made it all possible. So, here's one final question. Would you choose to live in a city built beneath the Earth's surface? For thousands of years, humanity has explored the surface of the Earth. We crossed deserts.
Looking for a piece of mind. I've been trying to redefine life. I can see the signs. Word is going to see me shine. Fighting for my soul's sake. Whipping fast, no brakes. Nothing's ever been a waste. Now that I've been wide awake, Luke's trying to pull me back in. I was done for a minute and forgot the passion. Since the lights turned on, it's been camera action. And you start to see it all like a chain reaction. Watch it happen, yeah. Swear that I'ma find my way. Past been gone, I'ma watch it all fade. Whoa, guess I'm going MIA from everybody's problems. Oh, guess I'm locked in, guess I'm locked in. I got this, and it's on my soul. Guess I'm locked in, guess I'm locked in. I got this, and that's on my soul. Time's moving, I've been losing track of where I've been. Had to quiet all the voices living in my head. I see the riches of the world, I'm not impressed. Know that I'm far from perfect, but trying my best. Looking up to the sky, feeling grateful. Boy, I had to walk away from the fake road. Can't believe I'm still here on my way to find out the truth. Swear that I'ma find my way. Past been gone, I'ma watch it all fade. Whoa, guess I'm going MIA from everybody's problems. Oh, guess I'm locked in, guess I'm locked in. I got this, and it's on my soul. Guess I'm locked in, guess I'm locked in. I got this, and that's on my soul.
The combination of human experience, advanced technology, and continuous innovation will determine how safely these remarkable structures serve future generations. That is why every inspection, every sensor, and every engineering decision matters far more than most people will ever realize. Would you choose life below the Earth's surface? Let us know your answer in the comments.